Hello guys, so let's start with question number 14 of HC Verma book. It says that a pendulum of mass 50 gram is suspended from the ceiling of an elevator. Find the tension in the string if the elevator goes up with acceleration 1.2 meter per second square, goes down with acceleration 1.2 meter per second square, goes up with uniform velocity, goes down with acceleration 1.2 meter per second square, goes down with deceleration 1.2 meter per second square, and goes down with uniform velocity. So first of all, let's draw a diagram over here. Consider this as an elevator and this as a string over here. Consider this as a bob. So let's start solving over here. First of all, it says that A part, it says that it goes up with the acceleration 1.2 meter per second square. So acceleration A over here. So first let's start solving. Acceleration A is equal to 1.2 meter per second square. After that, we have to find the value of tension in the string. So if this system is moving upwards, so means the tension is the leading force over here. So tension should be greater than the gravity of this bob. So it becomes tension T minus mg. What is the mass? It's a mass is 0.05 kgs. 0.05 into 10. That should be equal to 0.05 whole into 1.2. So tension T minus of 0.5, that should be equal to 0.06. So tension T will come out to be as 0.56 newtons. So we are done with part A. Now let's start solving part B. It says that it goes up with deceleration 1.2 meter per second square. So for B part, acceleration A is equal to minus of 1.2 meter per second square. So over here it becomes tension T minus 0.05 into 10, that should be equal to, over here it will become minus 0.05 into 1.2. So it comes out to be as tension T minus of 0.5, that should be equal to minus of 0.06. So tension T is equal to 0.44 Newton. So we are done with part B. Now let's start solving part C. It says that it goes up with uniform velocity. Over here, uniform velocity means acceleration A is equal to 0 meter per second square. So just putting the value of acceleration as 0, so it becomes tension T minus 0.05 in star 10, that should be equal to 0. So tension T is equal to 0.5 newtons. So let's start solving part D over here. What does the part D say? It says that it goes down with acceleration 1.2 meter per second square. Over here it is clearly mentioned that it is moving down. So so over here obviously the value of mg would be greater than the tension in the string. So tension will not be the leading force over here. Over here the leading force will be uh, gravity. So it becomes mg means 0.05 into 10 minus tension T, that should be equal to 0.05 into acceleration A. Acceleration A is given as 1.2 meter per second square, so it becomes into 1.2. After that it becomes 0.5 minus tension T is equal to 0.06. So tension T is equal to 0.44 newtons. We got the answer of D part over here. After that, so let's start solving E part. What does E part say over here? It says that it it goes down with deceleration 1.2 meter per second square. So over here deceleration is 1.2 meter per second square. So acceleration A is equal to minus 1.2 meter per second square. So it becomes 0.05 into 10 minus tension T, that should be equal to minus times 0.05 star 1.2. So 0.5 minus tension T is equal to minus times 0.06. Over here the tension T is equal to 0.56 newtons. We got the value of tension T. After that, let's start solving part F, last part of this question. Part F, what does the part F say? It goes down with uniform velocity. So again over here acceleration A is equal to 0 meter per second square. So 0.05 into 10 minus tension T, that should be equal to 0. So over here tension T is equal to 0.5 Newton. So this is all, we are done with the question. Just make a note over here, we have taken the value of G as 10 meter per second square, not as 9.8 meter per second square. Thank you very much.